Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on theory of numbers, lecture number 7, in which I will discuss some problems on division algorithm. Now we solve a problem. Problem number 1. Prove that any integer is of the form 3k or 3k plus 1 or 3k plus 2, where k is an integer. Now we solve this. Let n be any integer. Since 3 belongs to Z, 3 is an integer, then by division algorithm, n equal to 3q plus r. Q and r are integers and r is greater than equal to 0, less than 3. This is number 1. Q is called quotient and r is called remainder. Here value of r is either 0 or 1 or 2. Therefore r may be 0 or 1 or 2, because r here less than 3. Let r equal to 0 and q equal to k belongs to z. Then from 1 n equal to 3k plus 0 equal to 3k. K belongs to z. Let r equal to 1 and q equal to k. Then from 1 n equal to 3k plus 1. K belongs to z. This is number 2. This is number 3. Let r equal to 2 and q equal to k belongs to z. Then from 1 we get n equal to 3k plus 2. K belongs to z. This is number 4. From 2, 3 and 4 we get that any integer n may be expressed as 3k or 3k plus 1 or 3k plus 2. Proved. Now we solve problem number 2. Using division algorithm, prove that number 1, the square of any integer is of the form 3k or 3k plus 1, where k is a non-negative integer. Number 2, the cube of any integer has one of the form 9k plus 1 or 9k plus 8. K belongs to Z. Number 3, fourth power of any integer is either of the form 5k or 5k plus 1. K belongs to Z and k is a non-negative integer. Number 4, 3k square minus 1 is never a perfect square. K belongs to Z. Now we solve all problems one by one. Number 1. Since we know that any integer is represented as 3m or 3m plus 1 or 3m plus 2, m belongs to Z, means m is an integer. If n is an integer and n equal to 3m, implies that n square equal to 3m whole square, means 9m square. This equal to 3 multiply 3m square. Since m is an integer, therefore 3m square will be also an integer. Let this is equal to k. 3k, k equal to 3m square belong to Z. This is number 1. If n equal to 3m plus 1, m belongs to Z, then n square equal to 3m plus 1 whole square. This is equal to 9m square plus 6m plus 1. This is equal to, we take common 3 here, 3m square plus 2m plus 1. Since m belongs to Z, therefore 3m square plus 2m is also an integer. M is an integer and 3m square plus 2m is also an integer. Let this equal to k plus 1. Let 3m square plus 2m equal to k belongs to Z. Let this is number 2. If n equal to 3m plus 2, m belongs to Z, implies that n square equal to 9m square plus 12m plus 4. This equal to 9m square plus 12m plus 3 plus 1. Here we take common 3. 3m square plus 4m plus 1 plus 1. Since m is an integer, therefore 3m square plus 4m plus 1 is also an integer. Let this equal to k. 3k plus 1. Let 3m square plus 4m plus 1 equal to k belongs to z. This is number 3. From 1, 2 and 3 we get that square of any integer n is of the form 3k here 3k plus 1, here also 3k plus 1. That means square of any integer is of the form 3k or 3k plus 1. Therefore, from 1, 2 and 3 we get square of any integer is of the form 3k or 3k plus 1. Proved. Now we solve number 2. The cube of any integer has one of the form 9k, 9k plus 1 or 9k plus 8. Since in problem number 1 we have seen that any integer may be represented as 3m or 3m plus 1 or 3m plus 2 where m is an integer. If n be any integer and n equal to 3m, m belongs to z. n cube equal to 3m whole to the power cube equal to 3 square 3m cube. 3 square means 9, 3m cube. Since m is an integer, therefore 3m cube is also an integer. Let 3m cube equal to k. This equal to 9k. Let 3m cube equal to k belongs to z. Let this is number 1. If n equal to 3m plus 1 implies that n cube equal to 27m cube plus 27m square plus 9m plus 1 equal to, we take common 9 here, 9 3m cube plus 3m square plus m plus 1. Since m is an integer, therefore 3m cube plus 3m square plus m is also an integer. Implies that n cube equal to 9 multiply this integer is k. Let plus 1. Let 3m cube plus 3m square plus m equal to k belongs to z equal to 9k plus 1. This is number 2. If n equal to 3m plus 2, m belongs to z, implies that n cube equal to 3m plus 2 whole cube. This equal to 27m cube plus 54m square plus 36m plus 8. If we take common 9 here, 9, 3m cube plus 6m square plus 4m plus 8. Since m is an integer, therefore 3m cube plus 6m square plus 4m is also an integer. Let this equal to k equal to 9k plus 8. Let 3m cube plus 6m square plus 4m equal to k belongs to z. Let this is number 3. Therefore, from 1, 2 and 3, we get that cube of any integer is of the form in 1 we see 9k, in 2 we see 9k plus 1, in 3 9k plus 8. 9k or 9k plus 1 or 9k plus 8. K belongs to Z. Proved. Now we solve number 3. In number 3, we have to show that fourth power of any integer is of the form 5k or 5k plus 1. If a divisor equal to 5, then any number is represented as, any number n is represented as 5q plus r. Q and r are integers and r is greater than equal to 0, less than 5. Therefore, r equal to 0 or 1 or 2 or 3 or 4. If r equal to 0 and q equal to m, then n equal to 5m. n to the power 4 equal to 5m whole to the power 4 equal to 5 cube m to the power 4. Since m is an integer, therefore 5 cube multiply m to the power 4 is also an integer. Let this equal to k. This equal to 5k. Let 5 cube m to the power 4 equal to k belongs to z. This is number 1. Similarly, if r equal to 1, then n equal to 5m plus 1, r equal to 2, then n equal to 5m plus 2, r equal to 3, then n equal to 5m plus 3, r equal to 4, then n equal to 5m plus 4. We may calculate that n to the power 4 equal to 5m plus 1 to the power 4 equal to 5k plus 1. K belongs to Z. Similarly, in each cases 5m plus 2 whole to the power 4, 5m plus 3 whole to the power 4, 5m plus 4 whole to the power 4, we get that these are of the form five k or 5k plus 1. K belongs to Z. Proved. Now we solve problem number 4. In problem number 4, we have to show that 3k square minus 1 is not a perfect square. Since we have seen that the square of any integers is of the form 3m or 3m plus 1. Since square of any integer is of the form 3m or 3m plus 1. M belongs to Z. If 3k square equal minus 1 equal to 3m implies that 3k square minus 1 by 3 equal to m implies that m equal to k square minus 1 by 3. This does not belong to Z. This is number 1, this is number 2. Therefore, in this case, three k square minus 1 is not a perfect square. If 3k square minus 1 equal to 3m plus 1, m belongs to Z, implies that 3k square minus, we take this one left side, minus 2 equal to 3m implies that 3k square minus 2 by 3 equal to m implies that k square minus 2 by 3 equal to m. This does not belong to Z. This is not an integer, but we have assumed that m is an integer. Therefore, in this case, 3k square minus 1 is not a perfect square. Therefore, in any case, 3k square minus 1 is not a perfect square. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.